Reinforcement learning from human feedback, or RLHF. So this reinforcement learning from human feedback is a method of training machine learning models that involves incorporating feedback from human users to help improve the performance of the model. In traditional reinforcement learning, an agent such as a robot or an AI system learns to make decisions by interacting it with the environment and receiving feedback in the form of rewards. And the agent goal is to maximize the cumulative reward over time. But in this reinforcement learning from human feedback, human users provide feedback to the model on its decisions or actions. So the feedback may be in the form of ratings or rankings, or it may involve direct input from the user on what the model should have done. So this model is then updated based on this feedback, allowing it to improve its performance over time. For example, imagine a chatbot that is trained using this reinforcement learning from human feedback. So this chatbot interacts with user and tries to respond to their questions or requests. The user provides feedback on the chatbot responses such as ratings or comments, indicating whether the response was useful or not. So the chatbot's performance is then updated based on this feedback, allowing it to learn from its mistake and improve its response over time. This reinforcement learning from human feedback is found useful in applications where it is difficult or expensive to obtain large amounts of data, or where the data is subjective in nature. It's also useful in situations where the model needs to learn from the preferences and feedback of individual users, such as in personalized recommendation system. So in summary, this reinforcement learning from human feedback is a way of training machine learning models by incorporating feedback from human users to improve the model performance. It's a powerful technique that can be used to train models in a variety of applications, particularly in a situation where obtaining large amount of data is difficult or where the feedback is subjective in nature. Next comes the working of this reinforcement learning from human feedback. So this methodology of reinforcement learning from human feedback can be broken down into several key steps. First is the model training. The first step is to train a machine learning model using traditional reinforcement learning methods such as Q-learning or policy gradient algorithms. Then come the human feedback. So in the second step, human users interact with the model and provide feedback on its actions or decisions. This feedback may be in the form of ratings, comments, or direct input on what the model should have done. Then comes the model evaluation. So the third step is to evaluate the model's performance using the feedback provided by human user. The model performance is updated based on this feedback, allowing it to learn from its mistake and improve its performance over time. Then the model refinement. The fourth step is to refine the model based on its feedback received. So this refinement can involve updating the model's parameters, modifying its architecture, or adjusting the reward function used to train the model. Then iterate and refine. So the process of training, evaluation, refinement and retraining is repeated iteratively until the model reaches an acceptable level of performance. And this model's performance is continually updated based on the feedback received from human users, allowing it to learn from real world interactions and preferences. And finally, deployment. So once the model has been trained to an acceptable level of performance, it can be deployed in a production environment. So in simple terms, this reinforcement learning from human feedback is a process of training machine learning models by having human users provide feedback on the model's performance. This feedback is used to update the model's performance, allowing it to learn from its mistake and improve over time. This iterative process continues until the model reaches an acceptable level of performance, at which point it can be deployed in a real world setting. Now, next comes how to calculate this reinforcement learning from human feedback to mitigate gender bias by hand. So, this reinforcement learning from human feedback is a popular technique to ensure that a large language model aligns with ethical standards and reflects the nuances of human judgment and values. Without reinforcement learning from human feedback and large language model relies only on the data and would think doctors must be men because the data likely reflects existing biases in our society. So with reinforcement learning from human feedback, an LLM is given human feedback that doctors can be both male and female. And the LLM can update its weights until it begins to use them rather than him to refer to a doctor. So moreover, we hope that LLM not only addresses that specific bias about doctors, but also learns the underlying value of gender neutrality and applies it to other professions. For example, learns to use them to refer to a CEO, even though it was not explicitly taught by a human. So this Claude 3, which is released by Anthropic, sets a new high bar for safety standards. It uses an advanced technique called constitutional AI by extending this reinforcement learning from human feedback, enhancing the H with the AI. So how do this work? So let's have a walkthrough first. So we have given a reward model here, large language model, and two prompts. Two pairs, that is a prompt and a next pair here. So first train this RM or the reward model. So goal is to learn to give higher rewards to the winners. So preference is human reviews two pairs and picks a winner. Doc is him or doc is them, right? So calculate the reward for pair 1, that is the loser. Then we'll have a word embeddings. So look up word embeddings as inputs to this RM. Then linear layer. So multiply the input vectors with the RMs or the reward models, weights and biases, and we'll get a feature vectors. Then we have mean pooling here. So multiply these features with the column count vectors that achieves the effect of averaging the features across the three positions. Then output layer, that is multiply the sentence embeddings with the weights and biases. So here output or the reward is 3 here, right? So reward for the pair 2. So here the reward is 5. Then winner versus losers award. So we will calculate the difference between the winner and the loser award. Now this RM model wants to this gap to be positive and as large as possible. So 5 minus 3, that should be 2 here, right? Next, calculate the loss gradient, that is map reward gap probability to probability as a prediction. We'll take a sigmoid function, right? We'll take sigmoid of 2. Sigmoid of 2, that is we are taking this like this, so we are getting 3 raised to power 2, that is 0.9 here, right? So then we are calculating the loss gradient here, that is minus this one, 0.9 minus 1, that is minus 0.1. The target is 1 because we want to maximize the reward gap. And then run the back propagation and gradient descent to update this RM's weight and biases, right? Then we will have to work with the align the LLM. So update the weights to maximize the rewards. The prompt to the embeddings. The prompt has never received human feedback directly, as is the special start symbol here, right? Transformers, the here attention yellow, so feed forward, we are taking this thing. So then we are having output probability, so where we are applying a linear layer. Then we have sample, we will apply the greedy method, which is to pick the word with the highest score. So for output position 1 and 2, the model accurately predicts the next word because the model was trained to this. Then we have reward model. So next word is CEO is him, right? Is feed to the reward model. The process is same. So here also the reward is 3 here. Then we'll calculate the loss gradient. That is we set the loss as the negative of the reward. Okay, so we have set it as a minus 3. So converted this 3 to minus 3 here, right? And then as the loss is minimized, the reward is maximized here. LLM is most aligned to the human feedback. So the loss gradient is simply constant, that is minus 1. And you will run the back propagation and gradient descent to update this LLM's weights and biases. That is the red borders here, right? So you have understood this thing. Now let's calculate the things, right? So here we know that the number of columns are 3 here. Here the number of rows are 3. So multiply 500 with minus 101, we'll get minus 5 here, right? that is 5 into minus 1, 0 into 0 plus 1 into 0 minus 5 here, right? 1 into minus 1 plus 0 into 4 plus 0 into 1, that is minus 1, right? This way we have got this matrix. Next we'll multiply these two matrices, we'll get this. So here check the number of columns as 4, the number of rows as 3. So consider the last one as a bias and use our famous formula, that is y is equals to wx plus b. W is the weight, x is your input matrix, and this b is your bias, which is normally added to this product of weight and input matrix, right? So here multiply this 1 0 minus 1 with minus 5 minus 5 5 and adding this 2 here, right? So we'll get the 2 here, right? So when we'll multiply 1 0 minus 1 with this one and adding 2, we'll get this one. Now here we are taking the ReLU part, right? So in the ReLU, the negative terms are considered as 0. So in the next step, it should be 2 0 1. So when we'll do the next multiplication, it should, the negative value should be considered as 0, right? Next we have next matrix. So it's not a ReLU. So here the number of columns are 3, number of rows are 2. So just 1 1 multiply this with 2 0, adding 0 bias here. So 1 into 2 plus 1 into 0 plus 0. So it's a 2 here. 1 1 with this one, 0 or 4. We'll get the 4 because we are adding the 0 here. So this way we will get this matrix, right? So here we have taken a sample maximum, that is CU is him, right? So here in the reward model, we'll multiply both these matrices to get this. So check the number of columns as 4, the number of rows as 3. Use this formula y is equals to wx plus v. So 1 0 1 multiply this with 0 1 1, adding 0 here, right? 1 into 0 plus 0 into 1 plus 1 into 1, we get 1 here. Then we'll do this 1 0 1 with a 1 1 1, adding 0 here, we'll get 2. So this way we'll get all these results. Now we'll use a ReLU. So in the ReLU, this negative terms are considered as 0. So this minus 1, when we'll do the next multiplication, consider this as 0 here, right? Now we will do the pulling. So here we have just simply divided them by the 3. So 1 plus 2, 1 by 3 plus 2 by 3, that is 3 by 3. Here also multiplied these matrices with this one, we have got the things like this, right? So just remember this 0 0 0. When you're multiplying this now with this much, you are getting 0 by 3, right? In the next stage, you'll multiply these with this. So here the number of columns are 5. Here the number of rows are 4. So consider the last one as a bias here. So 3 3 3 minus 3. Multiply with this one. Adding plus 1 here. We'll get the 3 here, right? So here for the loss purpose, we have simply taken its negative. Okay, and for this loss gradient we are using it simple, it's minusing it with the target, so we are simply taking its minus 1, right? So minus 3 is taken as minus 1 here, right? Then for the reinforcement learning with human feedback, right? So here first we will take its word embeddings. So we'll check. So doctor is him, like this. We'll check where the doctor is. For we'll take its rows. Doctor is like this, doctor. We have taken the 1 1 0 here. Then we are checking is. So we have taken this. Doctor is him. Then we are taking this him here. Okay. So this is him. Okay, so we have taken the things like this, right? Mean pulling is 1 by 3, 1 by 3, 1 by 3. So here we have this matrix here. So multiply this with this here. So multiply both these matrices, will get this, right? 1 by 3 plus 2 by 3, that is 3 by 3, right? So multiply this one, we'll get the things like this. So here also, when we'll take, the next word is doctor is them. So we'll simply take this words, right? So doctor, first check for the doc, 1 1 0. So written this doctor, then is, then them, like this. And then in the next step, multiply both these matrices. We are simply taking the pulling, that is we are taking its average, right? Summing in this one. So 1 by 3 plus 2 by 3, that is 2 by 3 plus 1 by 3. So it's 5 by 3, right? So here we have taken, now we have done this thing. Okay, so just adding these things and we are getting the outputs like this. So here we are getting the reward as 5, here we are getting as 3. So maximum is 5. So next is winner minus loser. So 5 and minus 3, right? It should be 2 here. Then we'll take a sigmoid function. So when the sigmoid function 1 plus e raised to power minus z, so it should be 0.9 here. Then we will minus this with a target. Target is minus 1. So 0.9, so that is 1. So minus this one. So 0.9 minus 1, that is minus 0.1. Okay. So to summarize this, what we have done, we have simply done matrix wise multiplication. First multiply both elements of this matrices, will get this, then multiply this, then this, then this, and then this. Okay, so taken the loss as simply it's negative here, minus 3, right? Then loss gradient is simply taken divided by 3 minus 1 here. So in this one here we have taken just taken this word embeddings, right? The like doctor is him. So we have just taken that corresponding columns here, and then done the multiplications of these matrices, then these matrices, right? Here taking the taking its summation, so we're getting 3 here, here we're getting 5, then winner minus loser, so winner was 3 here, the here loser was sorry, here winner was 5, the loser was 3, 5 minus 3 is 2, then sigmoid function is e raised to power something like this, so it should be 0.9, then 0.9 minus 1, it should be minus 0.1, right? Then comes the applications of reinforcement learning from human feedback. So they have a wide range of applications in various fields, including chatbots. So reinforcement learning is commonly used to train chatbots, allowing them to learn from human feedback and improve their responses over time. For example, a chatbot that interacts with user on a website may receive feedback on its responses, allowing it to learn to better understand user queries and provide more accurate answers. Then comes the personalized recommendation system. So reinforcement learning from human feedback can be used to train personalized recommendation systems, such as those used by e-commerce websites, by incorporating feedback from individual users on the recommendation they receive. This allows the system to learn the specific preference of each user and provide more relevant recommendation over time. Then comes the autonomous vehicle. So reinforcement learning from human feedback can be used to train autonomous vehicles, allowing them to learn from human feedback on their driving decision. For example, a self-driving car may receive feedback on its decision from a human driver, allowing it to learn to make safer and more efficient driving decisions. And finally, healthcare. So the reinforcement learning can be used to train AI-driven diagnostic systems in the healthcare industry. So by incorporating feedback from human experts, these systems can learn to make more accurate diagnosis and treatment recommendations. Also, they can be used in the customer service, where they can train customer service chatbots, virtual assistants, allowing them to learn from human feedback. Then they can also be used in gaming, so where they can be used to train AI-driven game agents, allowing them to learn from human feedback, improve their performance in real-time strategic games or other interactive environments. So in simple terms, this reinforcement learning is a powerful technique that can be applied to a wide range of applications where machine learning models needs to learn from real world interactions and preferences. So by incorporating feedback from human users, reinforcement learning from human feedback allows users to learn from their mistakes and improve their performance over time, resulting in more accurate and effective system. Okay, thank you.